Okay, boys and girls, welcome to your video notes for day 3, Wonder Woman. We're talking about applying other relationships in circles. There are several theorems you're going to learn today. Make sure you know what they are, and we'll practice how to use them. First theorem we're going to talk about says that if a tangent and a chord intersect at a point on a circle, then the measure of each angle formed is half the measure of its intercepted arc. So the angle is half of the arc. So if we look at an example here, like in number 1, we have a circle. We have arc AB, which we can see is 30 degrees, and arc AB is intercepted by angle 1. So following the theorem, that means that the measure of angle 1 must be half of the measure of the arc. So the measure of angle 1 is 130 divided by 2. And 130 divided by 2 is, of course, 65. So the measure of angle 1 is 65 degrees. Here's another example. This one's opposite. They give us we're given the angle measurement of 125 degrees, and we need to figure out the measure of angle KJL. So if we look over here, instead of saying the measure of angle 1, we have 125 degrees is equal to the measure of angle LJK. It's the same arc. I just wrote the letters in different order. Divided by 2, because the angle is half of the arc. So if we multiply both sides by 2, we would then see that the measure of the arc is 250 degrees. Numbers 2, 3, and 4 are examples for you to practice on your own. We will check them in class. This next statement is fairly obvious, but we just want to point it out. If two lines intersect a circle, there are 3 places where the lines can intersect. Number 1, they can intersect inside the circle. Second, they can intersect outside the circle. And last but not least, they can intersect on the circle. So, we're going to look at how to figure out angle measurements in a couple of these situations right now. We've already dealt with if they intersect on the circle. That's the inscribed angles that we talked about last class. So here at theorem, if 2 chords intersect inside a circle, then the measure of each angle is 1/2 the sum of the measures of the arcs intercepted by the angle and its vertical angle. So if we look over here, these angles are vertical. They intercept arcs AB and arcs CD. So if I was to add those arc measurements together and divide it by 2, I'd get the measure of this angle or this angle, which are the same because they're vertical angles. Now, if 2 segments intersect outside a circle, then the measure of the angle formed is 1/2 of the difference of the measures of the intercepted arcs. So if it's inside, you add them. If it's outside, you subtract them. It can be like example 1, example 2, or example 3. These intersect outside the circle in all 3 cases. So you would just get the arc measurements, subtract them, subtract the bigger one, do the bigger one minus the smaller one so you don't get a negative number. Divide it by 2, and that'll give you the angle measurement. Here, we can see that P and R are points of tangency. So you'd have arc PQR minus arc PR. Divide that by 2, it'll give you angle 2. And here, the same way, you've got your arcs. Just get the arc measurements, divide them by 2. We're going to go over a couple of examples and then leave some for you to do on your own. You can see in number 5, these intersect inside. If you're a little confused on whether to add or subtract, you can almost see how when they intersect inside, it almost makes a plus. So we're going to add here. So the way we'd set this up is we're going to add the arc measurements and divide it by 2. So x is going to equal the sum of the arcs, 130 degrees plus 56 degrees, divided by 2. So 130 plus 156 is 286, divided by 2, and we end up with x equals 143. So the measure of that angle would be 143 degrees, as would the measure of that one. Number 6 is an example where they intersect outside. So if we look in the circle, that looks like a big minus sign. So we're going to subtract the arcs. So we're going to start out with x equals 178 degrees minus 76 degrees divided by 2. Again, always do the bigger one minus the smaller one. We're not going to have negative angle measurements. 178 minus 76 is 102. So x equals 102 divided by 2, and 102 divided by 2 is in fact 51. I want to go over one more example with you guys before I set you loose to do the rest. If we look at number 7, we can see that this arc measurement is x degrees, this arc measurement is 95 degrees. We have the measure of this angle, 102, but our theorem doesn't tell us how to deal with that. Our theorem only tells us how to deal with these angles, this one or this one. So what I'm going to go ahead and do is I'm going to go ahead and put a z over here and say, all right, this angle is z degrees, because then I can deal with that. Well, hopefully I remember back, and I see that this angle that's 102 degrees and this angle that's z degrees form a linear pair. And we know, hopefully, linear pairs are, that's right, supplementary. So that means that z is going to equal 180 minus 102. So z is 78 degrees. So then, using that 78 degrees, I can solve my problem. I know that 78 is going to equal the sum of the arcs divided by 2. So 78 equals x plus 95 divided by 2. Since I want to get this x by itself, what I'm going to do is multiply both sides by 2. Multiplying both sides by 2 gives me 156 equals x plus 95. I'll then subtract 95 from both sides, and I end up with x equals 61. So you may have to use linear pairs somewhere else in this practice homework. Just remember to set it up the same way. Add the arcs, divide by 2, and it equals the angle. Or you subtract the arcs and divide by 2, and it equals the angle. Finish up the rest of these sample problems to go over in class, and have a great day.